Hello everyone, and welcome to today's tutorial session on the for the course Introduction to Biostatistics. Okay, before we start off, we are in week 6 of the course, and any doubts regarding the course so far? Yeah, I mean, with any concepts, things that were covered in the previous few weeks or even just the previous week, please feel free to post your questions or ask your questions. Asking would be better. Anyone has any questions or doubts on the topics covered so far? Anyone? Okay, if that's not the case, we can just proceed with this week's tutorial. This week, you covered, I'll share my screen first. Can you see my screen, everyone? Yes or a no? If I don't get any answer, I will assume that you can't see the screen. So, can you see my screen? Can you see a blank screen which says Introduction to Biostatistics? Yes? Hello? Can you guys hear me first? Am I audible? Am I audible? Yes or a no? Uzma? I don't think there's anyone else. Oh, there are. Can you hear me, Uzma? I'm so sorry if I don't get any feedback, I might not be able to proceed. Miss Uzma, can you hear me? You're not, I think you're muted. I cannot hear you at all. Maybe you can type in and say whether you can hear me. Am I audible? Okay, maybe I'll just proceed with the presentation since I'm not getting any feedback. Okay, so we have more people who have joined. Am I audible? Can you please let me know if I am audible and whether you can see my screen? Hello? Am I audible? And can you see my screen? Uh, who's joined? Arun, can you see my screen? Am I audible? Arun? Okay, maybe I'll just proceed and if there are, I don't know, since I'm not getting feedback, I will, okay. Arun says yes, I am audible and my screen is visible. So I'll proceed. In the last week, you primarily discussed what central theorem is and some concepts regarding around that as to what your
Nina
sampling is.
baby, you Nina baby. Yeah, let's just that. Allow baby. तारा बुक पहले डायरी दिखाओ।
Someone's mic is on.
रोशनी ठीक है कि लैंप चलाऊं?
Okay. So the central limit theorem that was introduced to you says the following. Suppose you are given n random variables x1, x2, x3, and xn. Each of these are identical
काम
and
की शॉर्ट देते
independent,
हैं।
either independent and identically distributed. What do I mean by that? What I mean is all each of these x i's, that is x1, x2, x3,
डायरी
have the same mean and the same variance. That is, mean is mu and variance is sigma square. Then, as your n increases, okay, as n tends to infinity, the distribution of the sum of these random variables is approximately normal. Okay, so irrespective of what the distributions xi, x2, x1, x2, x3, xn are, what the distributions of these random variables are, given that they are independent and identically distributed, if you add them, then the resulting distribution will be normal with mean n mu and variance sigma square n. Okay, so that is what central limit theorem is. Why is this useful? It is useful because it basically says that if you have large sample sizes, your sample will tend to resemble a normal distribution. Okay, and once you have normal, you can do a lot of statistical tests which are very relevant in this course. For example, t-test, ANOVA, and things like that. Okay, or a z-test. Z-test is something that is given at the bottom. So if you have the mean and sigma of a normal distribution, only for a normal distribution, uh, you can calculate something called a z statistic, which is basically xi minus mu by sigma by root n. This is for the entire, yeah, okay. So z statistics is nothing but modulus of mu minus uh, x bar divided by sigma by root n. Okay, and just the z score is nothing but you don't have to take the modulus, you just do mu minus x by sigma by root square root of it. Okay? Now, given you have a mean of, say, if you have a population and the mean of the population is 20 and your sample mean is 21.4 and you're asked to calculate the z statistic and you've been given the standard deviation of the sample as well, then you can simply plug in values in this formula, that is modulus of mu minus x bar by sigma by root n, where n is, like, say you have 36 samples. So given you have population mean, sample mean, and then standard deviation and the sample size, you can calculate the statistics in the following manner. And if you just substitute values, you get something called as 2.1. Okay. And now having this, you can calculate what is this z distribution. It is a standard normal with uh, mean 0 and standard deviation equal to 1. Okay, so it's a standard normal. Given some value of z, that is, like, for example, you've got this 2.1 here, you can calculate the probability of getting this value or higher. Okay, how do you do that? You can simply use Excel, wherein you go to Excel and you type this thing equals norm dot s dot distribution and you plug in the z value you've got. Okay, and you write true. True means you get cumulative probability. Okay, so basically it's trying to tell you what is the probability of getting a z
डायरी
value. Yes, probability of getting a z value equal to or higher than
इस
2.1.
पेज नंबर 20 क्वेश्चन 5 निकालो।
Okay, and that is nothing but 0.98. Someone's mic is on, can you please shut it off unless you have a
ये
doubt?
ठीक है? क्या बात है? क्या बात है? अब तो कारी साहब को भी कहा है कि मगरिब के बाद आए, मेहरबानी खेलना है।
Usma, your mic is on. Can you please shut your mic off
क्वेश्चन
unless you
5
have a question?
तारा को उसका अपना घर तो दिखाओ, इतना प्यारा मेहरमा ने घर बनाया है, येलो और व्हाइट
I'll have
टाइल्स
to
वाला
mute you.
आईपैड में है।
I don't know how to
किधर?
mute individual members.
नहीं देखा होगा।
Your mic is on.
ग्रीन और व्हाइट
Usma,
टाइल
can you
वाला
please
देखा
switch
है,
it
ब्लू
off?
और व्हाइट टाइल वाला। अच्छा ज़ारा, वो जो इसका जो है वो जो
Okay, I
इसके
might have to
पूरे जो इसकी
remove you
बालकनी
from
है
the
ब्लैक
call
एंड व्हाइट
since it's
टाइल्स वाली
causing a
देखी है आपने?
disturbance. Okay.
जो वो तो नहीं ना आपने देखी, वो जो ब्लू और व्हाइट टाइल वाला इसका, वो कौन सा है स्टोर, ब्लू और व्हाइट टाइल वाला स्टोर देखा है? वो कहती वो तो नहीं मैंने देखा। और जारा की आंख पे इतना दाना निकला हुआ है।
I don't think.
मामा ने दवाई लगाई जारा, या मैं लावा है?
Okay. Okay, now let's continue. So we are trying to calculate what is the probability of getting a z-score equal to or higher than 21 or greater than 21. So you can do that by going to Excel and typing in this formula equals norm.s.distribution, and you need to plug in your z value and write true. So what this is giving you is probability of getting a value of 2.1 or higher, okay, in your standard normal, and that is nothing but it gives you 0.98. That is, you can get a value of 2.1 or higher given you can get a value probability of getting a z value of 2.1 or higher is nothing but 98 0.98. Okay, there are some questions related to this in your assignment. For example, calculate probability of getting a z value that is between say zero point 0.2 and zero point 0.9. Okay, how do you do that? You go to Excel again. In this thing, first you write equals norm dot distribution of getting zero point 0.2. Okay, you get some value. Now you calculate the same thing for zero point 0.9. Okay, so what it's telling you is probability of getting a z value equal to zero point 0.2 is 0.57. Uh, Probability of getting a value of z score of zero point 0.9 or higher is 0.81. So what is the probability of getting a z value between zero point 0.9 and zero point 0.2? You just have to subtract these two probabilities, that is this minus this, that is get a probability of getting z score of zero point 0.9 minus probability of getting z score equal to zero point 0.2, and that's nothing but 0.81 minus 0.57 equal to 0.23. Okay, so that is how you calculate. So answer equal to 0.23. Okay, remember what function you have to use. It's norm.s.distribution. Okay. Next, you have something, and then you also what was discussed was different kinds of sampling that you have. There, here are some names. This is not an exhaustive list. For example, the most basic one is random sampling. What is random sampling? It is sampling from a population without knowing any identity of any individual. You just suppose you're given a box of chocolates and you're asked to pick 10 chocolates. You pick the chocolates one by one, closing your eyes, without having any information of what kind of chocolate you're picking. Okay, so that's called random sampling, and it is in the it's very self-explanatory what the sampling is. You just pick things randomly. There are other kinds of sampling. For example, you have cluster and stratified sampling. So stratified sampling is when you have a non-homogeneous population. For example, you have a population of say one type of individuals here and one type of individuals here, and you want to sample equally. You want to sample such that you don't bias your samples with respect to each of these populations. For example, you don't want just blue in your sample or just red in your sample. Okay, so to do that, first you subdivide your population with a common characteristic. Say I divide my population based on say color, blue versus red, and then you sample proportionately from red and blue. For example, from the smaller sample you take 2, from the larger sample you take 3, and so on. And then you calculate your mean as and deviation. For example, you're calculating the height of individuals. You calculate the mean and variance of these in heights of these individuals from the individuals you have selected. Okay, so 2 red and 3 blue. You do stratified sampling to remove the bias of having more of just one kind of population. Okay, for example, you have more of blue and less of red, as opposed to cluster sampling where you have say somewhat equal representation of different of all the kinds of individuals in your population. You subdivide them, for example, into groups of 3, and you randomly pick any 2 groups or any n groups. Okay, so you basically divide your population into small clusters. Each of these clusters are almost on an average similar to each other. Okay, and then you randomly pick some cluster from this sample. For example, you pick this cluster and this cluster. and you calculate your statistics, that is mean or variance, whatever, by using just these individuals. Okay? So cluster versus stratified sampling, the only difference is that in stratified sampling, you divide your population into groups such that one group is of one type and the other group is of the other type, but they share some common characteristic. In the sense, for example, I'm dividing them based on language or based on color. Okay, so color is a common characteristic here, and then I pick individuals from these two things in a proportionate manner, depending given how big these groups are, and I calculate their statistics. Whereas cluster sampling, I just divide this group into clusters, wherein you have on an average homogeneous clusters, like each cluster is very similar to the other, and then you randomly pick clusters. Yeah. I suppose a systematic sampling, this is a kind of random sampling itself where you shuffle your individuals. Okay, for example, if you have 10 individuals, you shuffle them and you pick every second or every fourth individual. For example, here they have picked every second individual, so second, fourth, sixth, eighth, and 10th. And then you calculate your mean statistics. Suppose I'm interested in the height of these individuals. Okay, so I can calculate mean and height by doing this. So this is a way of again random sampling. I shuffle and then I sample every every say second individual or fourth individual or things like that. Now this is about sampling. Once you sample, you can calculate mean and standard deviation, which we have done in previous classes. Here I will introduce you something else known as confidence intervals. We have already hinted at this in some other previous tutorial, but this is the formal way in which you can calculate 95% confidence intervals. You can calculate confidence intervals for different kinds. For example, you can do it 80%, 90%, 95%, things like that. Here we will be calculating 95% confidence intervals because it is better to report the 95% confidence interval in most studies. Okay? What confidence intervals basically tells you is that what is the chance of finding the mean of my population. You can never actually get to the true population mean, but what is the chance of it lying between, say, some interval, for example, from some value to the other, okay, from say minus 10 to 10, what is the value, what is say minus 10 feet to 10 feet, and what is the probability of getting, say, height of giraffes, the mean height of giraffes to be between this. Okay? So to do that, you do confidence intervals. Okay, and for 95% interval, you use this formula mu, that is the sample mean, plus or minus 1.96 into standard error. Standard error we know is sigma by root s, square root of n, where n is your sample size. We get this 1.96 for only 95% confidence intervals. For different, say for 80%, this will be different. Okay, and it's these are you can get this from standard tables. So you just need to Google what is my t value for say 95% CI or 80% CI, and once you get that, you plug that value in here, and you can get your respective confidence interval. Now, given you have a mean of 22 and sigma equals 45, what is your standard interval? First, you calculate standard error at sigma by root n, uh, which is nothing but square root of variance also, okay? Because variance is sigma by root n, and suppose you are given the variance and not the standard deviation. Variance is nothing but square root of sigma. Sigma is nothing but square root of variance. So if variance was 45, you calculate square root of 45 divided by square root of n. So that's square root of 45 by 10, which is nothing but square root of 4.5, which is 2.12. So 95% confidence interval is nothing but mu plus or minus 1.96 into 2.12, and you get 22 plus or minus 4.16. So 22 minus 4.16 is 17.84, and the upper confidence interval, the upper limit of that is 22 plus 4.16, which is 26.16. So this is how you calculate confidence intervals. Now, I'll ask you a question. Tell me, for say a given data, some data, which one of these confidence intervals is bigger, 80% or say 95%? Which of these is bigger? That is, if you subtract the upper minus lower value of a confidence interval, which one will be bigger, a 95% confidence interval or an 80% confidence interval? Anyone? Anyone? 80%, right? 80% will have a small, sorry, the bigger will be 95%, right? Because you will be more confident when your range of your intervals, the width of your intervals is bigger. If it's smaller, then you will be less confident. Because, for example, if you just imagine, say, heights of individuals, and if I say the range of heights of, say, Indians is between 4 feet and 6 feet, I'll be more confident there than saying the range is between 5 feet and 6 feet. Okay, the confidence interval. Sorry, because the smaller the confidence interval gets, the less confident you are. Okay, so it's proportional in some sense. What else did you do in this thing? I think that's it. No, you did only how to calculate probabilities of Z scores between some intervals, different kinds of sampling, and calculating confidence intervals. I think this is all you need for this week's assignments. But if you have any other questions, I'm happy to answer them. Yeah. So this was what probability of getting a Z value of 2.1 or higher was 0.98. No? So if I just write 2.1 here, zero point 0.9 it was. Oh, so 0.98. I get 0.98. Okay. Any doubts with the assignment questions or what was covered in this week's lecture? Anyone?
I have doubt in movement generative functions.
Yes, tell me.
Movement generative functions, there's topic in fifth week.
Yes, yes.
I can't understand. This.
So, moment generating function. Have you been taught integration and things like that?
Yes,
Okay. So, moment generating function is nothing but, okay. Maybe I'll just. It's an expectation of e power tx. Okay. Maybe we'll do an example. I'll since yeah. Okay. Now we'll go here. Suppose x is a random variable. Okay. Moment generating function is nothing but calculating the expectation of e power tx, where x is your random variable. Okay, you understand this much, right? Now, given a probability distribution f of x, and that's a probability distribution is your exponential distribution. What is exponential distribution? Lambda e into e power minus lambda x. Okay, that's your probability distribution when x is real. Okay. So calculating the moment generating function for this is nothing but you need to integrate from, this is simple, minus infinity to infinity. F of x is what? Lambda into e power minus lambda x. And you need to multiply your e power tx with it, exponential of t into x. So e power tx dx, and you calculate the integral of this. Okay. So that is nothing but what they have done here. So once you do this, when you multiply exponents, you can calculate their coefficient, not coefficient. The powers can be added. Okay. So this becomes exponential of tx minus lambda x. You take the x common out, say exponential of t minus lambda x. And once you integrate that and you put the limit, so the integral of exponential t minus lambda uh, into x dx is nothing but 1 by t minus lambda. This expression, okay? For this, you need to integration, okay? So once you get
yes,
this, you just need to substitute the limits and you get the moment generating function, okay? For this probability distribution. So the moment generating function for exponential distribution lambda into e power minus lambda x is nothing but lambda by lambda minus t. Okay.
okay.
So that's how you get your moment generating functions. You just need to multiply e power tx to the e power tx to the probability distribution function and integrate it from minus infinity to infinity. So is that clear?
Yes, this is clear, but can you give me an example where it is used?
Uh, these are used when you have to calculate joint distribution functions and things like that.
Okay,
Yeah, yeah,
it's conditional probability, something like.
yeah, there and things like that. Usually there.
Okay, okay, I understand.
All also just for like even like univariate or for like say first order, second order, nth moment. Like you can get the mean or say for the first moment. Okay. Uh, how do I say? You differentiate only once. Okay.
Yes,
So this is my moment generating function, and now to get say the mean of what you call hmm, the mean of the what you call this probability distribution function. You have got the moment generating function, right? And you have for this distribution, this is your moment generating function. Now to get the first moment, which is the mean, you need to differentiate it with respect to t. Okay.
yes,
Okay. Once you do that, you get the mean. Okay. At t equals 0. Okay. And then if you want the standard deviation, you differentiate it twice at t equals 0. So that's this. If you want higher movements, for example, if you want the skew or kurtosis, you differentiate 3 and 4 times like that. Kurtosis is 3 times, skew is 4 times. And then you substitute t equals 0 because you need to evaluate it at t equals 0, depending on where you want to evaluate it. Yeah. Usually it's at t equals 0. Okay. And you get all these
yes.
results. So this is another way of getting your mean standard deviation for any given probability distribution. You can derive that.
Okay, I understand now.
Okay. Okay. Anything else? Anyone? It's self-explanatory. The name itself is called a moment generating function. No, to generate moments like mean, standard deviation, not standard deviation, variance, because the second moment is variance, from which you can get standard deviation. Yeah. Anything else regarding this week's assignment or previous assignments or previous whatever content covered so far? Okay, if there's nothing else, then we'll close for this session. There are very few people participating. I hope the numbers increase and then we can have longer sessions. I don't know. Or you can ask me questions on based on whatever doubts you have. If there's nothing, then I'll have to close. Is there any other further question? Okay. If not, then we'll end today's tutorial. I'll put the video up and the PPT as well. Okay. I think that's all you need to know for to solve this week's assignment. Okay. Thank you. And have a nice day.